Hello, welcome to the Beginner's Guide to Building an AI Model powered by Award Solutions. My name is Reece. I am Technologist here at Award Solutions, and I'll be the host of this complimentary webinar. In this session, we're going to give you an overview of building an AI model, training a model, and applying that model. We'll also show a demo as part of the process. Award Solutions is a proven leader in training with over 20 years of expertise. We will be presenting at the CCA Summit later this month, as well as Mobile World Congress Americas in October. By the way, we've reserved time at the end of the session today for question and answers. If you do have any questions, please feel free to ask those during the chat. I'll also try to respond to them during the presentation as possible. I also want to let you know we are recording this session, and we will send you an email with a link to the recording within the next couple of days. I would like to thank you for taking time out of your busy schedule to get a deeper understanding of artificial intelligence. To reward you for your interest in AI, I have something both to thank you and to encourage you to explore AI in more depth. I will send the link and the code in the chat, as well as after the session. If you send me a LinkedIn invite, I will send you the code so that you can receive a discount, a 20% discount on a bundle that we have that's a Welcome to AI on-demand self-paced learning, as well as a tech primer on artificial intelligence. There's a couple that are scheduled. One is scheduled for tomorrow, as a matter of fact, and another one in October. So what I'd like to do now is let's talk for just a second on what my plans are for today. And at any point, if you have questions or if you have something specific you want to make sure that we discuss, please do go to the chat window and put that into the chat. And just to let you know, if you do put something into the chat, I'm the only person that's going to see it. And so if you're trying to put something that's more of a general comment, I'll have to repeat it or send it to everybody else. So our agenda for today is we're first going to look at framing a machine learning problem. So artificial intelligence, there is a number of subcomponents to that. And one of the dominant subcomponents that we are looking at today is called machine learning. And so we're going to look at framing a machine learning problem. What does it mean to try to decide when to use machine learning as an approach to solving that problem? We're going to look at what it means to prepare the data. And preparing the data is a large piece of doing a machine learning analysis. We're going to actually go through creating a machine learning model, training the model so that it can learn from the data, and then we'll look briefly at how to apply that model so that we can use it for new predictions as well. I just want to make sure, is everybody able to hear me? If someone would, if you put into the chat to let me know if you can hear what I am saying. Okay, excellent. Thank you so much. So someone did put into Q&A that they weren't able to hear, and I wanted to make sure that it was not me. So sorry, I'm not able to address that at this point. All right, thank you guys so much. All right, excellent. Now, before I get started, what I do want to do is, since we've already gotten into the chat window, if you would jump into the chat window, let me know where you are with respect to doing AI projects, either personally or within your company. Are you just interested in it and exploring? Is it something that you're looking at in more detail? You've developed your own AI project. Where are you within your journey of this? If you'll enter that into the chat, that would be fantastic. And while you're doing that, I'm going to go ahead and move forward. So we're going to start with framing the machine learning problem. So what does it mean to frame a problem? Well, as we think about machine learning is not just this all-encompassing savior of everything. The way that we're using this within the industry today, it's kind of like we're going to use AI to solve all problems. I read an article that came out right after Mark Zuckerberg was on Congress, was testifying in Congress last year, for all of the problems that had come up with respect to Cambridge Analytica, and we're not going to get into any of that stuff right now. But every time a senator or a congressman would ask him a question, how are you going to deal with this? How are you going to deal with that? One of his responses was artificial intelligence, AI. And in this one article I read, they were saying it's kind of like a talisman. He's just going to wave AI and the problem is going to go away. That's not really true. We have potentially other challenges associated with that. So the first thing we need to do is we need to say what problems are really something that can be solved with artificial intelligence. What is the structure of the problem? I've had people come up to me and they say, well, I want to build an AI problem and here's my data set. And I'm like, okay, we can build an AI algorithm to solve that and we can spend 6 months and have pretty bad results. Or we can use a pivot table in Excel and we can have good results later today. We need to make sure that we have the right type of data. So let's look at what it means to frame a problem. So what makes a good ML use case? It needs to be something that is repeatable. If it's something that you're doing just one time, that doesn't really help us. It needs to be something that we want to do over and over and over again. One of my favorite examples of this is if you take a picture using your smartphone today, a box forms around the face of the people in the picture. Well, that's something that's repeatable. Every time you take a picture, I want to use an AI algorithm that detects faces so that we can focus the camera properly. It needs to be something that's computationally complex. I don't want something that is fairly simple. I don't want something that I could write a very simple algorithm to determine. I want something that has a lot of inputs and a lot of complexity, and that's what I want to build this model out of. I need to have a lot of data, homogeneous data. And if you ever go back and look at any of these data breaches, or you look at any of the stuff that happened again with the Cambridge Analytica, where people were using data that they really weren't supposed to have access to, why were they doing that? Why were they getting access to that data? Why did they want access to that data, I should say? Well, they wanted access to the data so they could build these models. Data is king. So that's really where the money is where that data is. Kind of a funny side story. I did go to DEF CON this year, and if you're not familiar with DEF CON, it's the big hacker conference that happens every summer in Las Vegas. And I'm a bit of a hobbyist in this area. And me and a colleague of mine, we were walking around at one point, and there was a couple of guys at this table, and it was a big sign that was called Halifax Analytica. And so I said, what are you guys doing? And he says, well, all data comes from someplace. And so if you happen to have a dumpster full of data that fell off the back of the truck, we'll buy it from you. So these guys were trying to buy data that hackers may have come across somehow. Just kind of shows you how important this data is. And then lastly, what makes a good machine learning use case is where the rules are very, very complex. What are the rules associated with the problem that you're trying to solve? So we talked a little bit about framing the problem. So let's spend a little bit of time now and talk about preparing the data. And this is very good. So most people that responded in my kind of informal poll a couple of minutes ago, their interests are kind of no experience, exploring, getting started, beginner sorts of levels. So probably the most challenging part of this is understanding how to take data and do something with it. So there's two key pieces with respect to this data preparation piece. We need to collect the data, and this collection of data is both acquiring it as well as doing some basic cleaning of the data, some basic sanity checking, identifying the key inputs or the key features. So if we're dealing with something in more of a telecommunications sphere, what systems am I pulling this data from? Maybe it's a radio access network. Maybe it's a core network. Maybe it's an operational management system. Where am I pulling that data from? And maybe it's from multiple sources. Most service providers today are building some form of a data lake. And maybe all I'm doing is pulling that data from that data lake. We kind of joke about it here at Award Solutions. We do technology training, and so we do have an amount of data of all the classes that we've talked about or that we've taught over the years. We kind of joke about how we don't have a data lake; it's more of a data puddle. So whatever your data situation is, you need to collect that data. When we talk about cleaning data, what we really mean is, how do I get rid of bad data? And I don't mean bad data as data that doesn't give me information I want. I'm not talking about trying to manipulate the data in some way. What I mean is, maybe it's data that I just don't have good information. Maybe it's data that wasn't collected properly, or there was an error or something like that. And so I don't want bad data to influence my results. After I do that, I'll do some form of actual preparation of that data, which we'll talk about here in a second. So when we think about data, there's two basic types of data. And again, this is really oversimplification. We have continuous data, which is really more numerical data. Something that is a continuous number thing. So maybe it's going to be pixels in a picture. Maybe it's going to be house prices. Maybe it's going to be stock prices. Maybe it's going to be the number of calls on a specific system, or the number of drops, or the number of handovers, or what have you. But whenever we're talking about a number of something, that's when I want us to think about this continuous data. And with this continuous data, the magnitude matters. And so if we're dealing with 10 call drops versus 20 call drops, well, 20 is more. Categorical data is more dividing things into categories or discrete data types. Maybe this is going to be words, or maybe this is going to be choices of things. So some of my favorite examples is if we were trying to do some type of analysis of phones, which types of phones sell more? One of the things I would need to include would be things like, what color is the phone? Well, blue isn't necessarily better than red. They're just different. I need to somehow categorize blue, red, green, yellow, what have you. So that's where the categorical data comes in. Typically, categorical data is going to be something that is discrete in nature, and we're usually going to have to do some type of a transformation of it to convert it into numbers so that we can use it as far as our algorithm, as our analysis is concerned. So let me give you a couple of examples of continuous data. Now, what you see on the screen is a set of data that is a common set of data that people use to learn how to build AI models. This is a set of data that's called churn. And the purpose of this data is to take all of this information about subscribers and see if we can learn what's causing them to want to change to a different service provider. And so you can see this last column here ends up being an important column because it's saying, did this particular subscriber, did he churn? No, this one didn't. Yes, this one did. So you can see we do have some continuous data here. The number of voicemail messages, the total minutes that are used during the day, the total number of calls, the total charges, the number of times we've called customer service. Now, this is fairly old data. So this is data when back before we do things that we do today, right? We don't really look at minutes of use in the same way that we used to. The number of minutes that people spend on the phone is quite different now than it was 10 or 15 or 20 years ago. I know for my kids, and all of my kids are college age or older, they don't make phone calls very often. The number of times I have a phone call is very, very rare. But this is an example of continuous data. Categorical data is something that is something represented in a category. Do you have an international plan? Yes or no? Do you have a voicemail plan? Yes or no? So then how do we prepare that data? Well, one thing we may do is we may remove some columns or some features associated with that data. There's some data that's just not really of any value. Let me give you an example. Let me back up a slide and show you. For example, we have a phone number here. I don't want the phone number that included as part of this particular analysis. And the reason because that is I could learn if somebody has that phone number, that's what's causing them to churn. I want something that's more generic. So I would cross out things like the phone number and the area code. There's other factors I might, subscriber IDs, the state I may or may not want to keep. I'm then going to go through and do a splitting of the data into a training set, a validation set, and a testing set. We'll talk about this a little bit more a little bit later in the process, but the purpose of this is to really test our model. Now let me take a step back. If you're familiar with what we're talking about with respect to artificial intelligence, there are three basic types of machine learning models that we can build, or three different machine learning approaches we can take. We can take something called supervised learning, unsupervised learning, and the other one I just drew a blank. It'll come to me in a second. With supervised learning, this is where we have reinforcement. Sorry about that, reinforcement learning. Supervised learning, this is where we have the input and the output, and what we're learning is we're learning how to take the input and predict the output. This is what we're focused on in this discussion today. This is the most common form of machine learning. Unsupervised learning, this is where we just have the input and we're trying to break things into groups. We're trying to see if we can glean some information about what makes, how to separate this data into different groups. We see this a lot in early marketing type analysis. And then lastly, with reinforcement learning, this is more of providing feedback. We see this a lot in robotics, where we're trying to teach a robot to do something, or in gameplay. We're trying to teach an algorithm how to play a game, and the way that we're teaching it is through providing it feedback. So what we're focused on today is really this first one, just to make sure that we're clear. I had a question that popped up on the Q&A. Some of the data would be unique identifiers like subscriber IDs, so we cannot remove, well, we want to remove subscriber IDs because we don't want to learn from that data. What I'm talking about there, and let me go back to this slide for a second, and this will probably help. It's a great question. What I'm trying to do, the goal of the problem I'm trying to solve is I'm saying, given, and I'll kind of clean this up a little bit, given all of this data here, how do I learn how to predict this? That's what I'm trying to do. I'm trying to do some type of a prediction of this churn column that's on the right. So that's my goal. So this is my input, and this is my expected output. So what is the data that's going to help me do that, and what's the data that's potentially going to mess up my analysis, for the sake of a better term? So that goes back to things like, is the state important? Well, I would say yes, because if I'm having some states with higher churn than others, I'd like to learn that. How much time, the number of months this account has been active. Okay, that's important. I don't think cell phone numbers are important because it's too specific to a person. It's not general enough, whereas the other things are general again. That's really the problem that we're trying to solve here, just to make sure that I'm clear. All right, cool. Okay, splitting the data. We'll talk a little bit more about that in a second. I might want to transform the data. And what this really means is I might want to change data based off of some factor. Let me give you my favorite example. Let's say that what I was doing is I was trying to build a model to predict house prices. And so I may have number of rooms, I may have square footage, and I may have year. Well, if I've got year and I'm saying, well, this house was built in 2012, or this house was built in 1987, or this house was built in 2019, does that absolute magnitude of that number really mean anything? Not really. And so what it could do is it could potentially change the nature of the way I'm doing that prediction. So what I might do is I might go in here and instead and say, well, why don't I change this to, this is 1 year old, right? This is 8 years old. This is 34 years old or 33 years old or whatever it is, for example. So therefore, the magnitude of this number doesn't have as much of a negative impact. It might. It's hard to say, it depends. So one of the other things that's important to think about is there is a bit of trial and error that does happen. But that's really what this transformation is all about. I need to convert categories to numbers. So for example, what I might do is I might convert yes to 1 and no to 0. Because everything needs to be a number. And then I might need to do some type of feature scaling, which is similar to the transformation. So that's preparing the data. So let me kind of show you a simple example of that. So what I've done, and this is a very common way that people approach this, is to use something called a Jupyter notebook. And so this is a Jupyter notebook. And I'm just going to run a couple of these cells. And what I'm going to do is I'm going to read some data. And then I'm going to let it run for a second. There it is. And so in this particular data set, about 73.5% is no churn, and about 26.5% is churn. And then the next few cells, I'm going to drop some data and do a little bit of cleaning of the data. So this is all of my different data that I have: gender, senior citizen, yes or no, partners, and all that kind of stuff. And here's an example of that data. So here is all of the data. And you'll see right now, I have the data has yeses and nos, and it has female and male, and it has words in here, not numbers. Contracts are month to month. This next cell does that transformation. And so, like for example, gender is it's replacing male, female with 0, 1. Do you have a partner or not? Yes, no, it's replacing to 1, 0, and so on. We'll run this cell. And so now you can see that the data is numeric in nature. And that's really the key thing that we've been talking about so far. All right, cool. Now, I've spent a good amount of time so far talking about data. And as a matter of fact, you might think, okay, we've really only covered one of our major sections that we wanted to talk about. Well, that's kind of intentional because data is such a big piece of this discussion. In a lot of analysis and a lot of AI models, you'll see that data preparation ends up being 70% or more of the time that you spend. Because if you don't have good data, then you're really not going to be able to do anything. Now we're going to create a model. So we're specifically going to use some type of artificial neural network as part of this example. And so we need to do things like decide the nature of that artificial neural network. And there's a lot of different types of artificial neural networks. And what we're going to look at is the most simplistic example, just so we can get a sense of this. If you're interested in this and you want to see a lot more models, there's something called Asimov's Zoo. If you just Google Asimov's Zoo, you will find a link to a white paper that will have hundreds of different types of models. We're going to look at artificial neural networks, which means it's going to be composed of a number of neurons. And each neuron is basically doing some math functions for us. So what are those functions? What are the math that it's doing? And then we're going to look at the number and types of layers associated with this. So let me kind of approach it this way. So this is a very basic way of looking at generating a neural network. So the first thing we're going to do is we're going to start with our input. So what is the input? What is the feature? So we'll use the term input. I like the term input because it's kind of simple. It's easy to understand. The technical term is features. They really mean the same thing. So I'm going to load those values in. Example, the stuff that we have up here. We're going to create something called an activation function. And all this is going to do is how are we doing some math associated with this model. We will have something called a bias associated with this as well. Now, I don't like this term bias. It's an unfortunate term because the term bias actually has two meanings in the English language. We use the term bias to represent a prejudice. So I have a bias towards drinking coffee. I love coffee. I drink coffee all the time. I have a bias towards coffee. I have a bias against tea. I don't really like tea. I've never really liked tea. And so we use that term bias sometimes to mean kind of a prejudice or a predisposition. I don't mean that here. What I mean here is the mathematical sense. A bias is just a constant that's added as part of an equation. So if you go back and think about your most basic formula from your first algebra class in middle school or junior high school, you might have something that says y is equal to 2x plus 1. Well, technically, this is that bias. And that's more of what we're talking about, is this constant that's added. Okay? Step 4 is another activation, and then we'll look at classifying the results. And we'll look at that a little bit more here in a second. So we need to build some type of a model. So we have our input data that's going in. We have our output that's wanting to come out, right? So our input data is all of this churn data. Actually, I'll call it subscriber data. And the output here is yes or no. And then we may have a number of layers that the data is passing through. And all these layers are doing is just math. Math. And what I'm really trying to find out is I'm trying to find out some weights so that I can come up with this really complicated formula to predict a value. So let me show you an example. So this would be a very simplistic example. I've got my input, comes in, does some math as the output. A more complicated one would be where I have a couple of layers here in the middle. And this would be an example where I have more neurons. So let me show you an example that I have in my model here. And it's right here. And as a matter of fact, what I'm going to do, just to make life a little bit easier on us, is I'm going to grab this. I'm going to move it over to here. So we talk about designing this model. This is the basic thing that we're going to do. We're going to pick a number of layers. And this particular model ends up having 1, 2, 3, 4 layers, and then one output layer. This one here is an output layer. I'm choosing, just because what I wanted to choose, I'm choosing 64 neurons in each of these. This first layer has 19 because this is the number of input values. And then this is my output because it's either yes or no. Specifically, it'll be more of 1 or 0. So that's what I'm trying to learn. That's what I'm trying to learn. So if I run the cell, so I've now built that model. So I've in essence built a model where I have my input, I have 3 internal layers, and then I have my output. All right, cool. So we've talked a little bit about building the model. We've talked a bit about preparing the data. Now I want to talk about training the model. The training part is the time that is probably the most time consuming. Not so much time consuming from a work you're doing, but the work that the computer is doing. So there is a lot of time associated with this step. Data prep is probably the most effort from your perspective as someone who's designing this. Training is going to be more of a time consuming step. So we need to define some things as part of the training process. We need to define what is our training strategy? How are we going to do this training? We need to have performance targets. And this is, in my opinion, one of the most important. What is good? So if I am trying to take a picture, I would kind of like the accuracy of determining what's a face to be pretty high. If you're only able to figure out a face 20 or 30% of the time, it's probably not going to be very good. Probably want that to be 95 plus. If you're trying to figure out if a subscriber is going to churn or not, maybe 75% accuracy is good enough. If you're trying to look at an X-ray and determine if there's a fracture, or there's some type of a problem, maybe you need to have a higher accuracy. There's other pieces associated with this as well, like how are we going to split our data up? We're going to have one set of data that's used as part of the training, and we're going to have another set of data that's going to be used as part of validating the data, making sure that the model is working well. And we may have something called overfitting, where we need to do something called regularization. So let me kind of talk about some of these things. So our real goal here is to train and do something called backpropagation. And what backpropagation is where we're taking our results and we're trying to learn how to make this prediction. We're going to adjust some functions to do this. So let me give you kind of a very, very simplistic example of this. You can kind of get a sense of it. So let's just say, for the sake of argument, what I'm trying to do is I've got a set of data, 1, 2, 3, 4. And I'm trying to create a function. So this is my input. And I've got an output. 2.1, 3.9, 5.5, 6.4. And I'm trying to create a function that says my output is equal to a weight or a value times the input. And the way that I'm going to approach this is very simplistic for the sake of this example. So for example, what I might do is randomly pick a number. Let's just say I want to pick this weight to be 10. Okay, so if the weight is 10 and my input, 1, 2, 3, 4, my weight is 10, the output is 10, 20, 30, 40. How accurate am I compared to the real results here? I'm pretty far off. So now what I want to do is I want to go through and I want to look at how far off I am and make an adjustment. Let's just say, for the sake of simplicity, since I'm high on everything, I'm going to try 5. Okay, so that gives me 5, 10, 15, 20. I'm still pretty far off. So let me take it to 2. 2, 4, 6, 8. Now I'm pretty close, and you can see I can kind of continue to refine this until this weight gives me a value that's going to give me a good answer. This is a very simplistic linear regression. My point is this is what's happening here, but instead of it being with 4 input values, 1 feature, 1 weight, it's actually hundreds or thousands of millions of weights that it's trying to learn. And that's what this step 7 and 8 is trying to represent. Is we're going to look at the error. We're going to do a process that's called a gradient descent. We're going to adjust the weights, and we're going to try again. This training, this is the real training that we talk about in building a model. Too many G's. This is the training that we talk about in building a model. And this is what can take a very large amount of time. So let me show you a simple example. Actually, I got one more slide. Let me show you that, and then I'll show you my simple example. So this is how a generic neural network works. So prior to all of this, I've already got the data processed. I'm building this model. Each of the neurons I've defined, and you can see here in my model, I've defined this is defining that neuron. I'm going to go through and pick a weight, see how close I am, measure my error, adjust the weights, and go through this again. And I'm going to go through this until either my results are acceptable or I just kind of give up, I run out of time. So let me show you this as an example. So what you see on your screen right now is the process of training. Now, for those of you who are interested, I'm actually using a tool called Reece with something else called TensorFlow. Reece is a Python library that helps simplify and abstract building an AI model. TensorFlow is actually doing a lot of the hard math for me. It's actually a library that was originally open sourced by Google. And what we're doing is we're going through a step of training. So we have 50 or 4,500 roughly samples that we're using. And we'll focus on this accuracy for a second. And we're currently able to predict, so given this data, given our weights that we started with, we're about 78% accurate. That's not bad. It's not great, but it's not bad. So we're going to go through and modify the weights and try again. Now we're about 80% accurate. We're going to modify the weights and try again. Now we're about 80.1% accurate. We're 80.1, a little bit better, 80.96, 92 to 96, 81. And we're going to keep doing this. And in this example, I decided to only try this 20 times. So now we're about 84.38% accurate. And that's where this chart comes in. So that is building the model and testing the model, running this data through the model to learn from it. Now, and this is not a good model. This is a bad example. And the reason that I kind of wanted to show this is I wanted you to see this particular model. This particular model, you'll notice this line starts to get worse down here. This line is better. This line is worse. This is a problem of something called overfitting. And what this means is that we're good at predicting the data, or we're good predicting the test, but we're not good at predicting all data. We're bad at all data, good at the test. And that's what this is showing. Kind of the example that I really like is kind of an analogy that I heard was if I wanted to give each of you a test, a 20-question test. Now, what I might do is I might tell you the answer to question 1 is A, the answer to question 2 is B, the answer to question 3 is C. So you could take this test and get 100% accuracy on it. But what if I were to change the answer order around? So the answer to 1 wasn't A anymore, it was B. It's the same question, the same 4 answers, I've just rearranged the answers. Well, now you wouldn't do very good. So that's what overfitting is you're good at answering this one test, but you're not good at predicting all data. Okay, so as kind of a transition into the last section that we have today, which is applying the model, because really generating an AI model and to where we are right now and stopping is really kind of boring. What we need to do is we need to be able to get new data and make new predictions. So what we have here is we have an example where somebody has put in an example new subscriber. And so this is all of the data associated with that new subscriber. Now, a little bit of background on this. I had an intern working for me build this over the course of the summer. And he didn't know what data to put here. And I was busy off doing other things. I'm the worst manager when it comes to that kind of stuff. I've had interns work for me for years off and on, and I'm always leaving them alone, and they have to figure stuff out on their own. So what he actually did, which I thought was really cool, is he went to some of the other interns and he asked, so describe your phone bill, right? And he actually put this together based off of one of the other interns, which I thought was pretty ingenious. So according to this, this is the prediction. So really what this is saying is if it's the closer it is to 0, the more confident I am that they're not going to churn. The closer this is to 1, the more I think they might churn. So in this particular example, we would assume this subscriber wouldn't churn. So if I were trying to use this in practice, what I would do is I would build an interface, take new data, run it through the model, and say, do I think they're going to churn or not? If I think they might, then what I'll do is I'll reach out to that particular subscriber and say, hey, I've got a discount for you, or is everything okay? Is there anything I can do to make you feel better? And so what this can do is this can help reduce that churn, which can be a huge cost saving. So what we've really been talking about for the last minute or so is how to apply the model that we've developed, right? So we've already gone through, we've gathered the data, we've created the model, and we've trained the model. And the output of this is we think we have something with good accuracy. If you don't think you have good accuracy, you wouldn't do this. What you would do is, if you've got bad accuracy, you would come up here and you would keep revisiting this and see if you can do better. But we think this is good enough. We think that 80% accuracy is pretty good. So now what we want to do is we want to actually apply that model. We want to be able to put this in a place that it can use new data. Now, in a perfect world, we want to be able to track how it's doing and maybe learn from that or modify that over time. But right now, we just want to really use this model on new data. There's 2 basic ways that we can use an AI model. We've trained it. We can either use it locally, and what this is doing is taking a trained model and building it into some type of an end device. So in this example, it's an autofocus on a camera. Maybe this is a security camera and it has a list of faces that if we see this face, we know that we should have some type of an alert. When I was at the GP Technology Conference in San Jose earlier this year, there was a company that what they did is they had a system that would look at security camera footage and it would determine, does it seem like there's something wrong going on, right? So maybe it's looking for some type of a weapon or some type of act of violence or some type of someone in distress, but it was basically trained on things like that. So in this example, we're taking the trained model and building it into a device locally. Now, the positive of this is it's fast because it's local. The negative of this is if I've got 1,000 of these devices, I've got to have this chip that does this. Well, that may be a lot of expense. It might be cheaper for me to deploy something more remotely and have the device do some type of an API call. It really depends on the nature of the problem that I'm trying to solve. The other way that we can deploy this is through an API call. So what I want you to think about there is I've got some cloud server someplace. Maybe this is Google, maybe this is Amazon, maybe this is Azure. So I've just got you can't hear me or see me. Okay, I might be on your side because I've got a spare computer here and it is still working. So sorry, you might have to catch this part on the recording. So I've got a cloud server that we're able to do an API call to. And this is we're going to send it the data, and it's going to send back a response. The value of this API call is it's typically cheaper. because I'm going to some type of a server in the cloud to do this type of processing. The negative is that it's typically slower, because now I have to go out to the cloud every time I want to do something like this. All right, cool. So that is pretty much what I had with respect to all of the slides that I have. And what I would like to do now is I'd like to open things up for any questions or comments before we wrap things up for our time we have together today. We've talked a little bit about the data cleaning. We had a couple of questions pop up about that. My experience so far has been using things like Reece, TensorFlow, and Python. And that's what I've been showing you here is some very simplistic Python code. And very, very easy to find examples of this, tutorials on this. If you look on Medium, there's just tons of tutorials out there. If you want to do something similar to what I've done, that's how I would get started. Are there any other questions that anyone has before we wrap up our time together? One question, will I share the presentation? Yes, you will get a link that will have a PDF of the presentation, and it will have a link to the video for any type of a replay if you would like to do that. Feel free to reach out to me via LinkedIn if you have any questions for me. Love to hear questions. As a point of reminder, and again, if you want the link, you can either copy the link down. Actually, I said I would put it in the chat, so I'm going to put it in the chat now for anybody who wants it. But if you don't get the link now, feel free to reach out to me in LinkedIn. Just look for Chris Reece at Award Solutions. I'm the only one, and you will find me. Also on LinkedIn, if you are interested in this field, there are a number of articles that we have written on building AI models and preparing data and those sorts of things. And so those are available for you as well. If you have any questions about Award Solutions, want to contact us, want someone to reach out to you, feel free to send us an email at info@awardsolutions.com. If you go to www.awardsolutions.com and you click on the resources link at the top of the page, you will have access to a number of videos that we've built, a number of white papers we've written, blog posts, and all of that. That being said, I want to thank you guys so much for your time today. Make sure I haven't gotten any new, I do have, I need to try Indian Malaysian tea I got from my comment earlier. The paid course, what kind of audiences is that for? It is a little bit more of a general purpose, kind of giving the industry perspective, as well as a little bit more detail on some of the stuff we've talked about today on building a model, kind of a little bit of both. It does have a lot of use cases that are being discussed. If you are in the Dallas area, there is an AI meetup that we have here in Dallas. Look for AI and Telecom on Meetup, and feel free to show up. If you're ever visiting Dallas, we meet on the third Monday of the month. Next Monday is our meeting here, so join us. Any other questions, comments, thoughts? And I have tried Malaysian tea, and it is pretty good. It was maybe an extreme example earlier. But otherwise, guys, thank you so much for your time, and I look forward to interacting with you again in the future. Next month, we'll have at the same time, second Tuesday of the month, we will talk about a beginner's guide to data visualization. See you guys next month.